Hello, I'm Svetlin Nakov from SoftUni, the software university. Together with my colleague George Georgiev, we continue teaching this free Java Foundations course, which covers important concepts from Java programming such as arrays, lists, methods, strings, classes, objects, and exceptions, and prepares you for the Java Foundations official exam from Oracle. In this lesson, your instructor George will demonstrate how to use strings to process text in Java, and working with text data in Java, which involves the use of the string data type, which contains an immutable sequence of text characters, and the StringBuilder type, which allows efficiently creating large texts. The string class in Java allows searching in a string, inserting and deleting substrings from a string, splitting a string by certain delimiter, joining several strings into a larger string together, and many other text processing operations. Let's learn them through live coding examples and later solve some hands-on exercises to gain practical experience. Are you ready? Let's start. Before we dive into the course, I want to show you the SoftUni Judge system, where you can get instant feedback for your exercise solutions. SoftUni Judge is an automated system for code evaluation. You just send your code for a certain coding problem and the system will tell you whether your solution is correct or not and what exactly is missing or wrong. I'm sure you will love the Judge system once you start using it. Let me show you how you can submit the solutions from your hands-on practical exercises to the automated grading system, the so-called SoftUni Judge. So you have a judging system designed to send you your code and it tells you whether the code is correct or not, and I will show you how it works. You open this link and you go on this website where is in the SoftUni Judge, and you click practice, and you have this Java full foundation course. These are the problems, and here you put your code just like it's shown here, and you submit and you send it. So for example, the first problem, student information, is this one, and this is your solution in Java, and you want to check whether your solution is correct or not. You click submit and it appears here, so you can refresh in a few moments and it tells you whether your code is correct or not. If you put some incorrect code, for example, I will format incorrectly the age and the grades of the output, and when I click here, it tells me that I have all the tests wrong, and in this case I can click the details and I can see that the expected input is like this, and my output is this one at the right. I have one additional digit which should not be there. So this is how the Judge system works. It will be your best friend when you are learning Java through our training courses, because as I repeat many times, learning Java is mostly coding and less watching videos. So you need to practice. That's why we have prepared a lot of coding exercises for you, and please do them because I want you to become Java developers. Before the start, I would like to introduce your course instructors, Svetlin Nakov and George Georgiev, who are experienced Java developers, senior software engineers, and inspirational tech trainers. They have spent thousands of hours teaching programming and software technologies and are top trainers from SoftUni. I'm sure you will like how they teach programming.
Hello everyone, this is George, I'm your technical trainer, and in today's lesson we'll be talking about text processing. So we will be talking about how we can manipulate text with Java, which basically means we're going to be covering the string class, which we've already seen, but we'll be talking about its functionality more and more, and we will cover some specifics which we haven't really talked about yet. And then we're going to be talking about not just how we can manipulate those strings, but using the StringBuilder class to efficiently manipulate strings and build them and modify their elements and so on. Okay, so today's lesson is going to be somewhat of a feature documentary. So we're going to be talking about the features in the string class in Java, but along with that, we're going to be talking about some concepts of text processing, which are general for all programming languages. So this lesson should be really useful for you, whether you're using Java or something else. We're going to be talking more specifically about why string concatenation is a slow operation when we get to the StringBuilder class. But first off, we're going to just cover the basic operations which strings support, and then we'll see how we can do them efficiently. So let's first cover what a string is. Now, strings are just sequences of symbols. They're sequences of bytes which represent text. Now, we've talked about this before. Any type of data in a computer is always ones and zeros. So whether you're storing numbers or you're storing characters or you're storing information about people enrolled in a university, for example, it's always going to be ones and zeros. So all data inside computers is just ones and zeros. And what matters is how you interpret those ones and zeros. So one sequence of ones and zeros interpreted as an integer may be the number 97, but that same sequence of bytes interpreted the same sequence of ones and zeros interpreted as a character will be the lowercase English letter A. So it really only matters how you treat the ones and zeros you have inside a computer. It doesn't really, there really aren't data types on the low level of the hardware of the computer. It's just ones and zeros, and we just treat them in different ways. So strings are sequences of characters, meaning that strings are essentially character arrays. So you have a char array, a character array, and that character array is wrapped inside a class, and that class has some added functionality which treats that character array in such a way that it can easily represent text from a human point of view. But it's still just bytes inside the computer. Now, you could use just character arrays, like I just mentioned. If you want to represent text, that's completely fine if you just need to store that text, if you don't need to do any special operations like searching for words inside it, or concatenation, or removing words and so on, or replacing information. And even in that case, you can also use character arrays, but instead of you having to write that on your own, all of these operations on a character array, there's the data type string, the class string in Java, which allows you to do these operations with built-in functionality instead of having to write it on your own, which is always good because you always want to use the built-in stuff if it's available and if it's useful enough for your specific task, because the built-in stuff has been tested out, it has been working for a long time, so you're certain that it doesn't really have any bugs in it. Whereas if you're using something you just wrote, well, you can't be completely sure that you haven't made a mistake somewhere, and that mistake could lead you to losing a lot of time while programming. So whenever you can use the built-in stuff, use that built-in stuff. And if for some reason that built-in stuff isn't available or doesn't really suit your use case, well, then you could use a character array to replace the string class. But for most of the stuff we're going to be doing in this lesson, the string class will suffice. So whenever you want to initialize a string variable, you use the so-called string literal in Java, which is enclosed in quotes. So these quote characters enclose whatever contents the string you want to enter in the Java code which you're writing. Whatever contents you want the string to be inside your Java code, well, you place that inside quotes. Now, this only applies whenever you're writing literals. So whenever you're literally typing in a string, which is going to be part of your program's memory when it runs, inside your Java code. Now, this isn't really extremely common. You might use it for some specific non-changing values, but typically you're going to be reading strings from the console or some other data source, for example, a file, a text file, or reading from the network, or reading from a web page or whatever. So this is the way you initialize it, but you won't really be using this too much. Okay, and if you want to enter a quote character inside the string literal, well, you need to escape it. We've seen that already, but let's cover it again. So if you want to make a string, so let's say this is the string text, and we want to initialize that text with hello world. If we wanted world to be in quotes, well, the way we do that, one of the ways we do that actually, is by escaping the quote characters like so. Now, you can't simply write a quote character over here because Java thinks that this quote character indicates the end of the literal. So instead of writing a simple quote, which would indicate the end of the literal, you escape that quote with backslash, which indicates, okay, so this backslash you don't treat as a character, but you use whatever character is after that backslash inside the actual string data. So this isn't a symbol in the Java code, anymore, which represents the end of a literal. It gets treated like a part of the string data which we're initializing, and the same thing over here. Now, we've covered this already, but I thought I'd mention it because it's good to rehearse that part of our knowledge. Okay, so what about single quotes? So these quotes over here. Well, it doesn't matter whether you escape, or actually you can't really escape a quote character. Well, you can write a quote character escaped. It's going to compile and work as you expect. However, you don't really need to do that. Why? Well, because these single quote characters are for character initializations, character literals. And in this case, we have a string literal, and they are the contents of that string literal. And they don't really break Java's logic of parsing that string literal, because it sees the first double quote and then searches for the second double quote. And in which case, if we had a double quote over here, that would break it. But since we've escaped it, it doesn't consider that one. So it's going to find this one, and then it's going to treat all of these values, this entire literal, as the string literal. Whereas these characters over here, it doesn't really treat them as anything important for the Java code itself. They're just contents of the string, just like any symbol inside the string is a content of the string. Meaning that because Java looks for a quote character, or for a second quote character whenever it finds the first double quote character, it won't really find these single quote characters because, it doesn't search for them. Okay, so that's escaping. We've covered it before, but I thought you could use a reminder. So this is how you initialize a string with this text. And all this really does is initialize a character array, and let's call it text array, and initializes that character array with the first symbol of, in this case, okay, let's remove these quotes so they don't confuse us. The first symbol is going to be H, and then the next symbol is going to be E, and then the next symbol is going to be L, and so on and so on. I won't write down all of it, but you get the idea. This is actually a character array which gets stored in a string object. So this text thing is an object of the string class, and the string class simply has a character array inside it. Okay, so that's what a string is. It's just a character array wrapped in a class which defines some operations over that character array, which allow us easier access to more text processing like logic. Okay, so whenever you create a string, unlike the character array, now they do use a character array underneath, but unlike the character array, the strings you create are immutable, meaning that this character array, I can tell it, text array set position, for example, 1 to the symbol, let's say O. So in this case, I'm going to be changing this E character into the O character. I can do that with a character array, but I have no such operation on the string object. So I can't say text set position 0 to the symbol, let's say B. That won't compile because there's no such functionality inside the string class, and there's also no method like in the list where we have set the value at index, some index, with a certain value, we can't change values inside a string. So there's no set something. Okay, so strings are immutable. That's what immutability means. They can't be mutated. They can't be changed. Their value can't be changed. Once you create a string, it keeps that value, and that value can't be changed. You can change the entire string. So currently, text points to this object over here. This is a string object, which is created. Text is just a variable which points to that string object. And we can tell it to point to another string object. So we can say text now equals, for example, ducks. Now what happens is we're not changing the contents of this object, we're just telling text that it now points to something else. It references another string object, and the string object gets discarded from memory at some point, and the garbage collector of Java collects it and frees up the memory it used to occupy. Okay, so that's what immutability means. An immutable string, all strings in Java are immutable, cannot be changed. Now, you can access values at an index, meaning you can say, give me the character at index 1, you just can't change it. So if I want to print out all the letters of this text variable, what I can do is say, run a for loop, starting from 0, continuing until you reach text.length and until you reach less than that. So when you reach it, stop executing. And then sout, not capital case, so sout tab, that writes out the system.out.println line. Okay, and now if we want to print each character on a separate line, what we need to do is just say text.character at, char at, and provide the index. In this case, it's going to be the index I, and this is similar to an iteration of an array, because again, strings are just arrays wrapped inside a class. Okay, and when we start this, we're going to see each of the characters inside the string on a separate line. Here they are. Okay, now you might say, okay, can't I get that character? So this is my character. Let's call it X. And can't I change that X character? Well, you can. Let's say initialize it to P, but you're actually not accessing the data of this hello world object over here. You're just accessing a copy of a character you received. Remember that whenever you're passing around primitive data types like characters, integers, longs, doubles, and so on, what you're passing around are actually copies of those variables. So when you have a character gotten from a string over here, well, that string returns a copy of the character, not the character itself. So when it returns, for example, this O character, it's going to create a new character, assign it with O, and give that to your X variable. So you're changing your X variable, and yes, when you're printing that X variable, it's going to be the P symbol. But if you then start printing again, and remove this assignment over here, and just print the value at that index, the character at that index, it's still going to be the same string. So this doesn't change the string itself. The same way that a for each loop, if you try to edit the iterating variable, if you say for each element I in a list of integers, if you edit that I element, it's not really editing the element of the list, it's just editing a variable which you have at your code, which is just a copy of the element of the list. Okay, so that's immutability, and even though there is immutability, you still have a right to access a value at an index, so that's how you access the values at that index. Okay. Now, strings in Java use the Unicode standard. What does that mean? Well, simply put, it means that you can represent pretty much any alphabet you can think of inside the Java string. So you can store Cyrillic, you can store Japanese, Chinese, Mandarin, you can store, of course, English, because that's the initial language which was used for computers when they were starting. Arabic, and any other language you can think of. So Unicode is a standard which covers all languages in pretty much all languages in the world. Even if we meet up with aliens at some point, it has enough spare room in it to put in more symbols if necessary. And actually, web pages typically use Unicode, so that's why you can open them in any place in the world, if they're coded properly, of course, and still see correctly displaying text. So Java strings are Unicode, and you can rely on that, meaning that you can store any type of string in it. So you can even say, okay, so let's initialize this string with the Cyrillic of Banitsa. And that is going to be a correct initialization of a string. Now, when you print it to the console, that might not render very well because some consoles don't really support Unicode. So the Java code supports Unicode and it handles it correctly. However, the console might not support Unicode. Let's actually test that and see what gets printed. Now I expect IntelliJ to handle it correctly. Yes, it did. So it printed the elements of that string correctly because it's inside the IntelliJ development environment, which probably has proper Unicode support for its console. Whereas, for example, the Windows console, which is the command prompt, doesn't really have Unicode support, and you have to make some specific settings in order to print non-ASCII characters. But that's not something we're covering right now. What you need to remember is that Java actually, with this Unicode support, supports any type of language, meaning that you can do text processing on any type of language in Java. And it handles, for example, toCapital. What you can do over here, one of the functions, it's a bit soon to show all of them, but one of the functions you can, one of the features which string has is changing itself to a capital case representation. So this is a lowercase representation of the word Banitsa in Bulgarian. It's a type of food, let's say. And this thing over here is lowercase, so you can change it to uppercase, so to make all the letters capital. Now remember that any operation, since the string is immutable, any operation you do on a string actually doesn't change the string itself. Again, the string is immutable. What it does is produces a new string. So any operation that is a change of the data doesn't change the data itself. It creates a copy of the data, changes that copy, and returns that copy. So what we can say now is replace text with the version of text copied, changed to uppercase, and then assigned back to text. So now what I'm going to see is this Banitsa text printed in capital case, so each of the letters is going to be capitalized. Now notice that Java handled this capitalization correctly. So it knows what the capital letter in Cyrillic for the letter B, the letter B in Cyrillic, it knows what that looks like as a capital letter, and it knows it for English, and it knows it for any other language which supports such a distinction between capital case and lowercase. Now what it does when it sees something that doesn't have a capital case, for example the numbers 1, 2, and 3, if you say to uppercase to 1, 2, 3, well, what's going to happen is they won't change. So to uppercase changes to the uppercase of the appropriate character only if that character has such a thing as an uppercase. Now, because 1, 2, 3 don't have an uppercase, they will simply remain the same. So over here we have 1, 2, 3, which remain the same. Okay, so we mentioned that. We mentioned the to uppercase functionality, but what was more important is that Java has full-fledged Unicode support. So what does full Unicode support mean? Well, non-full Unicode support means that you can just store the data, and you can do that in any type of character array because Unicode is again just ones and zeros. However, Java has full Unicode support because it, in addition to storing the information, it can also manipulate that information in a reasonable way. So if I'm searching for the word Banitsa in some text in Cyrillic, it will successfully find it. Whereas languages which don't have full Unicode support will not be able to find it or will not be able to capitalize the letters and so on. So full Unicode support means that you can do any operation on characters in any language. Any operation you can do on English characters, you can do it in any other language. That's what full Unicode support means. Okay, so We already showed you how you can initialize a string from a literal. Now how you read it from the console, we've already done it a couple hundred times already probably, is using the next line function or simply the next function. Just like you have next int, which reads an integer and reads it from where the white spaces stop and until the white spaces start. So if you have for some reason space, then space, then space, then a new line, then space again, then the text hello, then space, then for example tab, a tab symbol, you know, the tab key which inserts, let's say, 4 spaces for simplicity. If you say, if your console cursor is over here at the start of all the stuff I typed in, if you say .next, what you're going to get is this hello word. So it's going to ignore anything that's a white space character. White space characters are spaces, new lines, tabs, and other non-visual characters. So it's going to ignore everything until it reaches the first actual visible character, in this case the character H, and it's going to start reading the string until it reaches the next non-visual character, in this case the tab, and it's going to return the word hello after this code. So next will return hello in this case. And next line simply reads an entire line. That means it reads any white spaces and any tab spaces, whatever, until it reaches a new line characters. Okay, so that's how you read an entire line from the console. Now, what we haven't really discussed up until now in lessons past is how you convert a string to a character array and back. Now, I already said that a string is essentially a character array. Well, if you already have a character array, so let's get something shorter over here. So let's say you have a character array letters, and let's initialize it with a new character array containing the letters A, B, and C. If you want to convert that into a string, because I can't really print these letters out now in a single line of code. I can't say print letters. Well, I can, but they're going to get printed out in a special way, which is reserved for arrays in Java. Instead, what I can do is say get a string and call that string text, for example, and initialize it as a new string. Now notice that I'm using the keyword new, the same way I'm using the keyword new for lists, for maps, for other data structures. Well, the same way I can use the keyword new with the string class. Every class has, well, not really every class, but most classes have a so-called constructor. We've discussed constructors already. And the string class also has a constructor. Now, this call over here is equivalent to just typing into quotes without any spaces between them. So this is an empty string. However, if you pass in a character array over here, so if you pass in letters over here, it's going to initialize the string's internal character array with the character array you've passed in. So it's going to copy this data and initialize the string with it. Now, if I remove this for loop over here, what's going to happen is we're going to have the characters A, B, and C printed next to each other on a single line. Here they are. Okay, so that's how you convert a string into, that's how you convert a character array into a string. But how do we get the character array back from the string? Well, we say text.toCharacter array, to char array. Now you might, what this does, this returns a character array which is contained inside the text. So it's going to return an array equivalent to letters. So let's say this is a character array text characters equals text.toCharacter array, and this is the character array inside the text. So if you want to convert it back into a character array, this is how you do it. Okay, so you might have noticed that there are other functions over here. For example, you have get characters, and what this does is it gets a starting index and an ending index inside this text variable, and then it gets a destination character array and a position from which to start. So it moves this range of characters, it copies this range of characters into this destination character array from the beginning index. Now, this isn't really something you're going to be using that often, but you could try it out if you like. Okay, so once we've covered what strings are, essentially, let's cover how we can manipulate them, and then we're going to have a short break. So, how do you manipulate strings? We've already seen the plus and plus equals operators on strings. This is called concatenation. So concatenation means joining up strings one after the other in a sequence. Okay, so what does the plus operator do for strings? It's a specially coded operation in Java, especially for strings. So this is the only non-primitive type in Java that supports the plus operation and consequently the plus equals operation, the assignment with increment operation. No other class can support these operators in Java. In other languages, it's possible to define these operators for other classes too. However, in Java, the road that's been picked is for these operators to be explicitly reserved for primitive types, integers, characters, doubles, etc., and for the string data type to make writing string concatenation easier. So what this does, it creates a new string on each plus operation. So what it's going to do is, okay, so let's join up hello and this comma over here. That creates a string, and then it does the same operation over this string, and it creates a bigger string containing all of the text. So concatenation simply appends to the end of the string. So it appends the left string with the right string, whatever the right string is. So whatever's left of the plus sign is merged up with the whatever's right of the plus sign. I may have just misspoken. So about which gets concatenated where. So whatever is on the left remains on the left in the concatenated string. Whatever's on the right remains on the right in the concatenated string, and they become one string. They get joined. So in this case, what's going to happen is this plus operation is essentially going to join up these two literals, and then this plus operation is going to join up these two literals. So that's what the plus operation does. Okay, so getting back to the lecture, you can concatenate literals like this, so you can concatenate this literal with this literal and with this literal, but you can also concatenate on a variable. So once you have a string variable over here, if you concatenate the literal onto it, it gets appended, of course, to the end of the string contents. Again, this is something which we've probably seen a lot of times by now, so let's not hang on too much on it. Now, there's also a concat method. The concat method is just the longer expression of the plus sign. So concat and plus are the exact same thing. Whatever you write plus inside Java, it gets translated into concat. That's how you can think about it. How does it look like? Well, you tell the thing you want to concatenate to .concat, and then you provide a parameter what gets concatenated. So this is the exact same thing as saying greet plus name. And again, it doesn't modify this greet variable. It just creates a new variable containing the concatenation. So any operation on a string that looks like it's going to modify something, it's not going to modify the string itself. It's going to modify a new variable, a new string, which is the copy of the string you're using, and it's going to do whatever operations you've requested. Okay, so this will print hello John in this case. Okay, so now we have a task and we're going to solve that, and then we're going to see how we can do more operations on string. So what we have is an array of strings read from somewhere. Now what we have to do is we have to repeat each word, each string in these strings n times, where n is the length of the word that's been provided. So in this case we have hi, abc, and add. And we want to repeat each of these. Hi is going to be repeated 2 times, ABC is going to be repeated 3 times, and add is going to be repeated again 3 times. And we want all of this concatenated into a single string. Okay, so how do we do that? Well, there are a few ways we can achieve this, but since we now have sort of 2 parts of this task, so one part is repeat a single string multiple times, and then the other part is concatenate all of these strings together. What we're going to do is write some methods which do this work for us. Okay, so here we have some examples. Let's say work. So work is going to be repeated 4 times because it's 4 letters. So repeat it 4 times and we get work, 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 work. That sounds like one song that was popular at some point. Whatever. So let's do that. We are opening an IntelliJ development environment, and now what we're going to do, well, we have a line of strings on the console. How did we read a line of strings from the console? Well, we need a scanner first, so let's create a scanner and tell it to read from system.in. Okay, so this is our scanner. And this scanner, we're going to tell we want to read a line with it because we have a line of strings, and that line of strings contains splits by spaces, so it's going to be split by spaces. So we want to split it by that space. We've done that already, and what we're going to get is a string array of words. Now, what we need to do from here on out is go onto each word, and for each word, repeat it n times. So what we actually need is a method which returns a word repeated, a string repeated n times, where n is a parameter which we can provide. So what I'm going to write over here is a static string repeat method, and it's going to get a string s, and it's going to get an integer times, how many times we want to repeat it. So we'd be calling this repeat method like so. We'd be saying repeat the word hello, let's say 5 times if we want to achieve what the task says. So we have 5 letters inside hello, and saying repeat hello 5 times would yield a new string, which is the result string repeated, let's say, which is equal to repeat hello 5 times. Okay. Now, I'm going to remove this in a bit, but I'm going to leave it for now so we can remember what we want to achieve. Okay, so we know how many times this string is going to be repeated. Now, how can we repeat a string? Well, there are several ways, and there's a way inside the slides which is shown, and I'm going to show it when we solve this task, but we're going to solve this task in a different way from the one that's shown in the slides, and at the end of this lesson, you're going to learn why I did that in that way. Okay, so what I'm going to do now to repeat the string n times, of course, I can append to its end itself the number of times which has been specified, but I will not be doing that. Instead, I'll do the following thing. I'll create a string array which contains the repetitions of this string. And how long is this array going to be? Well, it's going to be as many elements as there are repetitions of the string. So let's create a new string array which contains times elements, so this number of elements. And then I'm going to be doing some magic over here to fill in the string array, and then I'm going to be returning string.join, join up this string array repetitions with no delimiter, with an empty delimiter. So this is string.empty. Okay, so all I need to do now is fill in this string array with this string. Each element needs to be this string. So each of the elements in this times length string array is going to be the string which is received as a first parameter of this method. So starting from 0, continuing until I reach times, I need to set the index I to the string s of repetitions. Okay, and now what's going to happen? Well, if I provide hello with 5 times, what's going to happen is we're going to initialize an array of 5 elements, and then we're going to assign each of these elements to the word hello, and then I'm going to join these hello words with no delimiter and return that. So that gives me the word hello repeated 5 times. Okay, and now all I need to do is walk on each of these words, meaning that I need to access each of these words, create its repetitions, and then build a string which contains all of these repetitions. So what am I going to produce at the end? Well, I'm going to produce a single string, and that single string is going to contain all of the symbols which I'm going to be generating. So this is my string result, and that's an empty string initially. And then I'm going to walk on each of these words, meaning I'm going to visit each of these words. And then I'm going to say, okay, so append this word to the result, but not the word itself. I'm going to say result, append. What do I need to append? Well, I need to append this word, its length amount of times. So what I need to do is say append the repetition of this word.length amount of times. So repeat this word this amount of times. And now I'm going to out tab print this out on the console. So I'm going to print out result on the console. Now, this part I don't like. Why? Well, I'm appending to a single string. I intentionally avoided doing that over here, but I can't really do it. Well, I actually can. I actually can avoid appending to a single string multiple times. And we're going to talk about why I want to avoid this at the end of this lesson, so hold on tight. Until then, what actually do I want to achieve? Well, I essentially want to achieve the same thing, right? So I want to have an array which contains each of these words which I'm repeating. And then, so each of the repetitions is just a single string of that word repeated multiple times. So I'm going to actually create an array, which is called result. So this is a string array result, and that gets initialized with how many elements are there going to be? Well, as many as there are words. So words.length. Why as many as there are words? Well, because each of the words gets repeated n times, where n is its length. And what I get in the end is a single string. So for each word, I get a single string. So there's a direct correlation between the words over here and the strings over here. Okay, so now, instead of doing this type of loop, I'm going to create an indexed for loop, and I can tell IntelliJ to do that for me. Okay, so I'm getting an indexed for loop, and then I'll just be saying result at position I, assign that to the repetition of this word. And then I'm not going to be printing result, but I'm going to be printing what? This join operation, right? So I'm going to be joining in the result without any spaces. So I avoided concatenating onto the same string. And now if I start this code, I assign each of the result elements to the repetition of the appropriate word, each one word at a time, and then I just join up all of these repeated words. So now if I open this code and I mark this hi ABC and add, and I enter it, I get the output that was expected. Okay, so one way of concatenating strings efficiently is just create an array with enough elements and then copy the strings which you want to concatenate. If there are multiple elements you want to concatenate, it's more efficient to create an array with, if you know the length which you need. If you don't know the length which you need, what are you going to do? Well, you're going to create a list, right? Because lists can be joined in the same way with string.join that arrays can be joined in. Okay, so you're going to create a list of strings if you don't know the length, and an array of strings if you do know the length, and then you're going to assign each element of that array to the string which you want on that position in the result. So you're somewhat appending to an array, and then you're joining up that array into a single string without delimiters. Or if the task requires some delimiter, well, then you'd provide the delimiter over here. And we did pretty much the same thing over here when we repeated a single string n times. Okay, so we solved this task, and here's another solution for that task, which uses string concatenation. Here, what we do is we just run a for loop on each of the words, and then we figure out how many times we need to repeat the word, and then we run a for loop and just start appending to the string result. Now, this will solve the task, but it's very inefficient. It's very slow, and we will explain why it is very slow at the end of this lesson again. I showed you a more efficient way of doing it, and then I'll show you another efficient way of doing it when we reach the end of the lesson. But again, this is one other solution to this task. Okay, now up until this point, all we've been talking about is how we can create new strings from existing strings. We've been concatenating, we've been accessing the entire string object. After the break, we're going to be talking about how we can access parts of the data of the string. And now we're going to be talking about how we can work with the contents of a string. Up until this point, we've been using the entire contents of a string. But from here on out, we're going to be talking about how we can access parts of those contents of the string and what features Java has for doing that. So one common operation in programming when you're doing text processing is getting a substring of an existing string. So what's a substring? Let's open up IntelliJ. Well, let's say I have my string text, which is equal to hello, what's up? And what a substring is just a part of a string. So hello is a substring of the hello, what's up string, and what's is a substring, and LO comma space W is also a substring of the text string, and up is space UP is also a substring. So a substring is just a sequence of characters, a sequence of elements inside a string. There's also such a thing as a sublist or a subarray, which is just a part of respectively a list or an array, the consecutive elements of a list or of an array. So a substring is just consecutive elements of another string. Also, the entire string is also a substring of itself because it's a substring which has the same length as the entire string. So this is also a substring. Okay, so let's get a substring of this text. It's very common for text processing programs to get parts of a string and do something with them. Okay, so let's say we want to get this what's part. How do we get that? Well, since every element inside the string has an index, now this is index 0, and this is index 1, this is index 2, this is index 3, the second L, and index 4 is the O, we got shifted a bit, and index 5 is the comma, and index 6 is the space, we're here. That means that what's starts at index 7, right? So it starts at index 7 and it continues on to index 8, index 9, index 10, index 11, index 12. That's the last one. And the first symbol after the last one is at index, where did we get? We got to 13, I think. Let's count again. 7, H is 8, A is 9, T is 10, the apostrophe is 11, the S is 12, and this space over here is index 13. Okay. So how do I get a substring in Java? I say text.substring, and I provide a beginning index. In this case, it was 7, the start index, the first letter I want to get. And then I provide a second parameter, which is 1 past the last index. The same way you write a for loop by saying that I should be less than the length of the, let's say, array. In the same way, here when the length of the array is 1 more than the last element, well, here we provide 1 more than the last element as an index. So in this case, we're providing index 13. So this gets a substring from 7 inclusive to 13 exclusive. So it never reaches 13. It reaches, the last index will be actually 12. So if you say, I want a substring from 7 to 13, that's going to give you the characters from 7 to 12 inclusive. 13 is the place where the for loop has to stop. That's how you can think about it. The same way you provide a length when you're iterating an array and you say I is less than length. The same way you provide 13 here, which would mean that I is less than 13, which would mean that I, the index, is going to reach 12 inclusively, get that character, and then stop. Okay, so this is, if we print this to the console, we say sout, we can print the text.substring from 7 to 13, and that's going to give us the what's word. Okay, so here we have it, the word what's, we got it as a substring from the string. So that's all a substring is. Now, there are other ways you can call substring. For example, you can say substring start from 7 and you don't provide an end index. What it does in this case is just take up all the symbols up until the end of the string. It doesn't matter how many of those symbols there are. Wherever the string ends, that's where your substring is going to end. It's pretty common to do such operations. For example, if you're working on a Windows file system and you want to get the extension of a file, what do you do? Well, you find the last dot inside the file name. For example, you have hello.txt. You find the last dot, and then you get a substring starting from the next index. And you don't really care how many indices there are, right? You just care that you get the entire substring. So it may be .txt, or it may be .gz, or it may be .something else, .bmp, .png, and so on. They are different lengths. So what you do is you just say .substring from some point onward, and you get the entire substring to the end. So printing this will yield us what's up on the next line after the line of just what's. That's what substring does. It's a pretty simple operation. Of course, you can implement it yourself. You just write a for loop, and then you start appending inside a string each character of the string you're looking at. So substring just starts a for loop at this index and continues up until the for loop reaches this index. When it reaches that index, it doesn't take the character. Or if you don't provide a character, if you don't provide an end index, it just continues on until the end of the string. Okay, so that's what substring does. In this case, getting a substring from the card 10c will just give you 1 and 0, because this is index 0, this is index 1, and this is index 2. And getting from 0 to 2 means get all the characters from 0 to 1 inclusive, 2 exclusive, we don't reach 2, and that gives us the string 10. Okay, so if you just provide a start index, in this case the 11th index which we're providing here is this index, we're just going to get, actually the 11th index is this one, so we're going to get space John. And that's what we have over, maybe space John, maybe not, I have to count the characters. Okay, let's count them. So 0, 1, 2, no, don't forget the spaces, 3, 4, 5, 6, 7, 8, 9, this one's going to be 10, and I'll mark it with a 0. So this one's going to be 10 over here, so John is 11, this is index 11 over here. So yeah, that means that we're just going to get John from John to the end of the string. Okay, so that's what substring does. It starts a for loop from this index until the index is less than the second index, or until the index is less than the length of the string, and it returns the characters that the index visited. Now, another thing you can do on strings is search their contents. So if you say index of, that's going to return the first match of a string you provide over here, or the index -1. So it's either going to return the first match's index, so the index at which it starts, or it's going to return -1. So in this case, if I say text.index of, and you can provide characters here, or you can provide strings, both work. So if I say print the index of what's, so s out this thing, print this thing, what's going to get output is 7, because that's the index of the W character inside inside the string text. So here we have 7. Now, if I say index of what's like this, so without the apostrophe, is what's contained inside the string? Well, no, it isn't. There's no such string which contains 5 characters, which contains WHATS. There's a string that contains WHAT apostrophe S, but that's a different string, right? It's a different sequence. It might contain the same characters plus one more, but it's a different sequence. So this one is in the middle of, it's inside the string I'm looking for, so this will not be found. Now if I start this, we're going to get the index -1. So -1 indicates to us that there's no such index, there's no such substring in our string. Now if there was a string over here, which is, for example, what's up, like this, it's going to find it. Why is it going to find it? Well, because here's the sequence, right? So if I search for this inside of IntelliJ, look, it finds it, right? It's this sequence. Even though there are more things after it, IntelliJ Java doesn't really care what's after it. It just cares that it matches this sequence of elements. Whether there are spaces after it, or other letters, or numbers, or any type of other character, it's still going to find it if it's the same sequence. Okay, so this is going to yield, what would it be? How many symbols are there up to here? There are 17 characters up to here. If you mark some text in IntelliJ, you can see how many characters it contains over here. Okay, so those are 17 characters, so this piece of code should print out 18, right? So because this is the index of what's in the string. Let's see. I might have miscalculated, but I think that's what's it. Actually, starting from 0 is going to print 17, right? Because there are 17 characters up until here. So this means this is the 18th character, but since we're starting from 0, right? So this is the first character, but since indices start from 0, this is going to be 0, right? So since this is the 18th character, since this is the, let's keep the colors consistent, since this is the 18th character, it means that it's the 17th index. Okay, so if there are 17 characters before a certain character in a string, its index is 17. Okay, so it printed out this one, not this one, because this sequence of characters is not the same as this sequence of characters. Okay, so it returns -1 if it doesn't find it, and it returns its index if it does find it. Okay, so in this case, in this example, if you initialize a string with banana, kiwi, apple, and so on, and you say, give me the index of banana, it's going to give you 0, because banana starts at index 0. It doesn't matter how long it is, it matters where it starts. Okay, and orange is going to give you -1, because there's no such thing as an orange in our fruits string. So -1 is not a valid index for an array, right? That's why the result is -1, because you know that it can't be a correct index. So this definitely guarantees that there's no such thing inside the fruits array. And again, this is something you can code yourself. How do you do it? You run a for loop and you check for finding the first character. If the first character, if the character at position I of the for loop equals the first character of the word you're searching for, then you check for the next character and the next character. How do you do that? With another for loop. So one for loop for iterating the text, and another for loop when you detect inside the text iterating loop, another nested loop which searches for the next character. So if you find the first character matches, then you check the next character of the string you're searching for with the next character inside the text, and so on. But instead of writing that on your own, you can just use index of. And last index of does the same thing that index of does, but it starts from the back. So if you search for apple with index of, so how many characters are there? Well, it's going to find this apple. If you search for index of for apple, but if you search for last index of, it's going to find the last apple. So it basically does the same thing, but it starts in reverse. So it starts looking from the last item over here. So if you look for banana, it's going to find this banana instead of this banana, if you use last index of. If you search for orange, it's still going to return -1. Okay. Now, one more thing you need to know about index of. Let's say you have a letter. Let's say you have a string twice. Like, for example, we have up over here. How do I find? Okay, let's say you have it 3 times. By the way, searching is case sensitive. So if you search for up capital case, you will not find it. You will find this one. But if you search for up capital case, if there's no up capital case, it will not find the lowercase up. Okay, so if we have up 3 times, how do I find the middle one? Or if I have it multiple times, how do I find the nth one? So I can find the first one with first index of, I can find the last one with last index of. How do I find the one in the middle? Well, I do. Let's say I want to find, I have an integer n, and I want to find the nth occurrence. So if n is 1, I want to find the first one. If I'm searching for up, I want to find this one. If I'm searching for the second one, well, n is going to be 2, and so on. How do I do that? Well, I can say int occurrence, which is the current occurrence for which I'm searching, and let's say that's 0. So I haven't found one yet. And now I'm going to say while occurrence is less than n, so while there's something to be searching for, I'm going to say text.indexOf, and let's say it's up, the thing I'm searching for. Otherwise, this would be just a string variable, which I provide as a parameter. So I say this is the index, index at which I found it. Okay, so this is the index. And if the index is not -1, then I found something. Since I found something, I need to increase the occurrence by 1, right? So occurrence plus, I found 1. Okay, so the moment that occurrence reaches n, I would have found at index the last index of this up thing. So what I do is move this index outside, set it to -1, because in that case I will just indicate I haven't found anything. And then I'd say index equals text.indexOf up. And when this loop completes, what's going to happen? Actually, let's cover the case in which I find -1. If I search for up and I get -1, do I need to search any more? No, because that means there aren't any other occurrences of up. So actually, this loop is good. I'm going to change it a bit, and I'm going to do if index is equal to -1, I have no job looking anymore, so I can just break the loop. Nothing to do here anymore. However, if I don't break the loop, I need to indicate that I found something. So when I exit this loop, what's going to happen is that index will contain the index of that substring up for which I said I want to search. Now, this isn't really true at this point, that's my idea, but it isn't really true because indexOf always starts from the last place where I started indexOf always starts searching from the start of the string. Now what I want to happen is I want this index to, if I find the first up, then I want the second indexOf to start looking from after that index. So I want to start looking from index +1, and I can provide that as a parameter. So the second parameter of indexOf is the index from which to start searching. So if I provide 0 over here, which is going to be the case for the first execution because -1 + 1 is 0. So if I say search for up from index 0, it's going to find, if there's an up at index 0, it's going to find that one or the next one after that. And if I find one up inside the string, then I assign that to the last index I found, I increase the occurrences, and then the next time I start searching for index +1. So when I find this up, I'm going to start searching from the P next time. So that will not find this up, if I want to continue searching, of course. It will find the next one, it will find this one. And then I'm going to start searching from the P of this one, and then I'm going to get this one at the final part. So now if I print out that index, what I'm going to get is, let's wait a bit, 14, which, where's 14? Well, 14 is over here, right? So up until here, there are 14 characters. So this first up is at index 14, which is exactly what I indicated over here. Now, if I want to find the second up, I will just modify this n over here to 2 and start it. And then I'm going to get what index? Well, there are 23 characters up until here. So this is index 23. And that's what I got. So here you have a piece of code which finds the nth occurrence of a string, inside another string. So what I wanted actually to show you is what the second parameter of indexOf does. It tells indexOf to search from this index onwards. So disregard anything before this index and start from this index onwards. Okay. Now another thing that strings have is the contains method. What does the contains method do? Well, it does an index of and then it checks whether that index is different than -1, right? Because that's how you check if a string is contained inside the text. You just search for it, and if you can't find it, meaning you get the return value of -1, then that means that the answer of the Boolean question, is that string contained in that string? Well, it's either true or false depending on whether you got -1 or not. Okay, so if I say I love fruits as a string, save that as a string, and then I search inside that I love fruit string for the word fruits, that's going to give an index that's different than -1, right? Since the index is different than -1, the result is going to be true. Otherwise, if I search for banana in the same string, I'm going to get the index -1, and since the check is -1 different than -1 is going to return false, well, that's why this method returns false. So this method returns either true or false based on whether a certain substring is contained inside a certain string. Now, it is sometimes useful because sometimes you don't really care about the item itself, but you care about whether it appears in the substring or not. But in most cases, I'd advise you to use index of, because in most cases, if you're searching for something, you're probably going to be doing something with it. Okay, so now we have a text, and we have to remove all substrings of a word from that text. So for example, here we have ice, and we have K, ice, G, ice, ice, C. This might be a bit wrong considering the output. So we have ice, and we have K, ice, then G, ice, then again ice, then B. So what does that give us? Well, K, G, and B. We've removed all ices from here, and we got KGB. Okay, and if we want to return to remove ABC from here, what do we get? Well, we get TTQ double. This is also not exactly correct, right? Because we have a C over here, and that has to be removed too. Let's see if this example is correct. So we have word over here, and then word over here, and yeah, only ABC remains. So this example is also not exactly correct. So this is the proper output for this example. Okay, we fixed that up. Hopefully you've been watching carefully. You need to watch carefully. This sort of examples sometimes may be wrong, so you need to be vigilant and look for such errors. Okay, so we have these three examples. What we need to do is remove a certain word from a certain string. We need to leave the string containing only the letters which are not part of that word. Now, there are a few ways you can do this, a few interesting ways. One option, the obvious option based on what we know up until this point, is what? Well, we can start from the beginning of the string and then search for the keyword which we've been provided with. So I search for the first occurrence of this ice, and I get the substring from where I am currently to the first position of this ice. So I get a substring from, let's say I'm at position 0 now, and I get a substring from position 0 to the index of this thing. So index of this thing is 1, right? So I get a substring from 0 to 1, and that gives me the letter K. And then I need to continue on. I need to set my current index to the letter G, right? I need to skip this word. Well, I get its index, the index to which I reached, and then I jump as many characters as the keyword is long. So at index 1, if I add 3 symbols, I get index 4, right? So I'm getting over here. I'm positioning myself over here at index 4. And then I repeat the same thing. I look for the next index of the string, and I get that substring from 4 to, in this case, 5. Okay, so I get then G, and I append it to my string, or I add it into a list which I'm going to join up at the end. Okay, and then what do? Well, I move from this position 3 positions forward, because that's the length of my keyword, and I arrive at position 8. Okay, so this is position 8. And here I immediately find ice, right? So there is no substring over here. I'm going to get the substring from index 8 to index 8. and that's going to be the empty string. And I add it again into the list. I don't need to do any special handling. I mean, I might do special handling if I see that the substring is empty, there's no point in adding it. But if I add an empty string into a string, that doesn't really change the string I'm constructing. So I can have the code do the same thing. And then 8 is going to be summed up with 3 again, because that's the length of my keyword, and I'm going to get 11. And then I'm going to search for ice again. So from 11, I'm going to search for ice, and I'm going to get -1, because there are no more occurrences of ice, right, from here on out. So I need to do special handling for -1. If I see -1, what do I need to do? Well, in this case, I need to get the string up until its end, but I'm at its end, so I'm getting that string. So what's the logic? The logic is create a list of strings, and then start at position 0, and each time search for the next occurrence of the keyword, get that index, in this case 1, get that index, get a substring from the position you are at now, so this red thing I'm writing in, that's one of your variables, and the other variable is the search. Okay, so get the substring from the red variable to the blue variable, from the position you are at now to the position of the next ice occurrence, the next keyword occurrence. So get that substring, add it into the list of strings. And then change your current index to be equal to the search index plus the length of the search word. And that only if the search index is different than -1. The moment the search index becomes -1, you just get a substring from your position to without an end position, meaning to the length of the string, and you add that into the list of strings. And when that while loop, that would be a while loop because you're changing the index. When that while loop finishes, what do? Well, you simply join up the list of strings into a single string, and that's the result. Now, you can do it a few other ways, and I'm going to use another way to do it. Well, no, actually, the other way is in the slide. So let's do that. Let's do this solution using our index of knowledge, which we have up until this point. Okay, so instead of reading input from the console, I'll just use the input I've generated over here. So let's say I want to remove all ups from this text. So how do I do that? Well, let's try. Now, what will I do? I'd say, here's my current position in current index or current position, and I'd start from 0 because I want to start from the first symbols in my string. Okay, and now while the current position is less than the size of the string, is less than the text dot length, I'd say, well, current position first. Find the index in search index. Find the index of, let's say this is the keyword, string keyword, and let's say it's up. Again, you can modify it afterwards at home so that this input gets read from the console and this keyword also gets read from the console. But here we're not learning about how we can read from the console. We're focusing on the algorithm for processing a string. So the search index is text dot. It's actually better to call it the keyword index. Okay, so the keyword index is find inside the text the keyword, right? But since I'm doing this on each iteration and the current position is going to change, I'm going to provide current position as a start index from which we're searching. So I'm going to be searching from the current position onwards. And the first time it's going to be from position 0 onward, so inclusively. So that's okay. And the next time when I change the current position, well, it's going to be searching from after the current position. And actually, that seems okay for me. Okay, so now let's get the index. So if the index is different than -1, if keyword index is different than -1, if I found something, then I have some work to do. Now let's create our list of strings in which I'm going to be adding the parts. So I want to add this part inside the list of strings, and then I want to add this part inside the list of strings, and then I want to add this part inside the list of strings. Okay, so what do? Well, this is my parts list, new array list. I don't know how many parts there are going to be, so that's why I'm using a list, not an array. Okay, So if the keyword index is not -1, then I found something. Then I need to get the next part. So the next part, this part, is the text. Give me the substring. So I'm getting the substring from the text. Which substring? Well, from the current position to the keyword index. I don't want to include the keyword, right? So that's why I'm providing the keyword index, because this index over here is exclusive. Okay, so this is my part, and I just need to add that part into the parts.add part. And then I need to move my current position, right? How much further do I need to move that current position? Well, I need to move it to the position after the keyword. So I need to say that current position is the keyword index where the keyword starts. So in this case, it's going to be index 14 because there are 14 symbols over here in the text I've marked. So index 14, and so this is index 14, this is index 15. So I want to avoid index 14 and 15, and I want to go to index 16, right? So I need to add 14 plus 2 plus the size of the keyword. So keyword index becomes, position becomes keyword index plus keyword dot length, the length of the keyword. Okay, and this finds, this is almost everything I need. Now, one additional thing I need to do is if the keyword index isn't -1, meaning if the keyword index is -1, in this case it isn't -1, and in the else it is -1. So in this case I do parts.add everything that remains, because there are no more keywords of this kind. So add everything that remains. How do I add everything that remains? Well, I'm at position current position, so I need to add text.substring starting from current position, and that's it. And then I need to just break the loop, because I don't need to search anymore, because I've added everything I need to add. Okay, so let's print that out and see if it works correctly. So print out string.join parts, join that with no delimiter, with an empty delimiter. Now I could assign this to a variable, and I could actually make this entire thing into a method, right? But I'm just going to join it now and print it out into the onto the console. Okay, so let's see what's going to happen. I expect to see hello, what, then that up doesn't exist, then 2 spaces, then this what's again, and then 2 commas, because these ups need to be removed. And that's exactly what I got. Okay, so that's one way to do it. Another way to do the same thing is to use the replace method. Now, instead of getting what I need, I'm removing what I don't need. So what does replace do? We'll see it in a few slides. Replace gets a string which we need to, we're calling it a key here, or a keyword in my example. So what replace does is it finds the string which you want to replace, and then it replaces it with another string. So you can just replace each item. Now this replaces all of them, so a single replace should actually do. So you can just say text.replace the keyword with an empty string. Instead of doing this entire thing, you can just replace inside the string with the empty string, and that's going to give you the result, and then print out the result. Okay, we're going to see the replace in a bit. First, let's talk about splitting. So what does splitting do? Well, you give it a so-called pattern. In the next lesson, we're going to be talking about regular expressions, and that's the pattern you're providing over here in the split part. So split gets a regular expression over here. A regular expression is just a rule that determines a pattern of strings which need to be found or replaced or so on. So in the split case, whatever you provide over here gets the string gets split by it. You've already done it by providing spaces. You can also provide comma and space. You can provide a word over here and so on. You can provide a lot of stuff. So this splits by spaces. But if you want to split by multiple things, you place these multiple things inside these square brackets. So you place square brackets, and then you mention all of the things you want split. So everything you want that text to split by. So in this case, it's going to split by the comma, the space, and the dot. So you're going to get this string, then this empty string over here because it's between a comma and a space. Then you're going to get I, then you're going to get am, then you're going to get John, then you're going to get this empty string between John and the dot, and then you're going to get one more empty string after the dot. So that's what this split by multiple separators does. Okay, so this is splitting. Splitting just removes all of the occurrences of the symbols you've enumerated here, the symbols which you've provided here, and leaves you with a list of what parts remain without those separators. And it gives you an array for that. So this is going to give you hello, I am, and John, and that's going to contain the split text. Okay, so that's how you split by multiple separators. Again, we're going to have an entire lecture about regular expressions and what this text over here means and what this plus means and how it removes the empty strings I mentioned while I was talking about this, because I initially said if you split by this, you're going to get empty strings in some position, but if you split by this, you're not. So again, this is something which we're going to be talking about a lot in the next lesson. But for this lesson, all you need to know is that split simply removes these items from the string and converts everything else in the string into an array of strings which which are between these items in the string. Okay, so we've done this a few times already, so I will not be staying on this much more. The more interesting subject is splitting by multiple separators and by patterns, but we will not be discussing this right now. However, one thing you could do is for this substring task, in which you had to replace everywhere you encounter the keyword, well, what could you do here? Well, one option, although I wouldn't advise for it, would be to say the text dot split that into, in this case, ice, right? What will that do? Well, it will split it by this sequence of characters, meaning it will give you an array of strings, and that array of strings will contain the string k, it will contain the string g, and it will contain the string b, and that array of strings you can join up into a single string. So you can solve this task with splitting too. It essentially would do something similar to replacing, but it will give you an array of strings instead of a single string, and you can join that array of strings into a single string. So you can split this way, you can split a string this way, and it's going to solve this task also. So that's why I said there are a lot of ways to solve this task. But I'd suggest using the replace method. It's probably going to be the most efficient of all of them. Okay, so let's talk about that replace actually. What replace does is it gets something for which to search and a replacement with which to replace. So you get, again, a new string. Anything that looks like it's going to modify a string, well, it will not modify the string. It will just give you a new string containing the result after the replacement. The old string will remain whatever it was. So in this case, we have hello John at softuni.bg. And if you replace that with, if you say replace John at softuni.bg with John at softuni.com, what you're going to get is the text with all positions containing John at softuni.bg replaced with John at softuni.com. So replace replaces everything in Java. So replace simply replaces all the occurrences of a sequence of characters in Java. There's also replace all, that it depends what kind of parameters you're passing in. So here we have a task in which we have to do something similar to that. So we have some banned words. In this case, the banned words are Linux and Windows. And then we have a string. This is a single line. We have a string of text, and we need to replace each of these words, each of the occurrences of these words, with asterisks. And the asterisks need to be the length of the length of the word. So each symbol over here needs to be replaced with an asterisk. Okay, so how do we do that? Well, we have a replace function, so let's read the keywords. Now, we're getting the keyword separated by a comma and a space. So we're going to get the text from the scanner.nextLine, but we're also going to read a scanner.nextLine before that, which contains the separators. So the separators in this case, not the separators, the banned words are these. So we're going to get a line, and we need to split that line by a comma and a space, because that's what our separator is. This is the separator. So we have this entire string, and we need to separate it into Linux and Windows. So we need to split by comma and space. Okay? And those are our banned words. Okay. So we need to replace each of these banned words with asterisks. How do we do that? Well, let's try. Let's remove this code over here. We'll remove the text also. So each of the banned words we find, we need to replace it with asterisks as long as that banned word is. Okay, so what I'm going to do is I need to do this for each word, right? I could iterate the text and then for each position in the text check whether from that position in the text there's one of the banned words, but that's a bit more difficult. What I can do instead is just say for each of the banned words, give me the text and replace. What does replace do? Well, replace accepts a string which is a regular expression or a character sequence and a character replacement. So if I say replace, that's going to want a character sequence. Now you might be wondering, what's a character sequence? Well, a string is a character sequence, and there are other things which are character sequences, but a string is a character sequence, and that's why there's replace without replace O, and there's replace O, which accepts a regular expression. So replace O will accept a regular expression for about which we're going to talk about further on, and replace simply like this will expect just a sequence of symbols which it needs to find and replace. So what do I need to find? I need to find the banned word. And what do I need to replace it with? Well, I need to replace it with asterisks. Asterixi, maybe? Not sure what the multiple of that word is. So I need to replace it with this symbol, repeat it as many times as the word is long. Well, how do I do that? Well, I already have a method which does that, right? It repeats a string a certain amount of times. Sure, the string is just a single asterisk which I need to repeat, and I need to repeat it. Okay, let's say repeat this asterisk string with what amount of times? Well, the banned word amount of times. And replaces everything. So every occurrence of the banned word is going to be replaced with this thing over here. Okay. However, and notice that IntelliJ is warning me about this, however, this replace over here doesn't really do anything, right? Because the way I've written it now, I'm expecting it to modify text. But it isn't modifying text because, again, strings in Java are not mutable. They are immutable. So you can't replace, you can't edit this text directly. What you need to do, this generates a new string, and you need to replace the current text with the text with these modifications. The same way you do for a sum, right? You have an integer sum, and then you're, let's say, iterating items in an array, and then you're summing into the current sum. So you're saying the current sum equals the current sum plus the integer. So you're replacing the sum variable with itself plus the integer. So a sum plus an integer is just a new integer. It doesn't change the existing sum. It just creates a new sum, and you assign it back to the sum which you had. So when you say sum plus equals integer, that's the same as saying sum equals sum plus integer. And in this case, we're saying text equals text.replace, because this generates a new string, and we assign that new string to our old variable, and we're getting rid of the old variable's value. So we're getting rid of the previous string which did contain that banned word, and assigning to our variable a string that doesn't contain that banned word. Okay, so how do we print this out? Well, we just say sout and print out the text, and that's it. Let's start this code and copy the input. So we're getting Linux and Windows on the same line on the console, pasting them in, and then we're replacing Linux with 5 asterisks, asterisk I, or whatever their multiple is. And if there was Windows in this input, we would have replaced that as well. Notice how replace replaces all occurrences. So there's Linux over here, and Linux over here. And a single replace for that banned word, because for Linux, when banned word was Linux, this is only a single execution. We haven't done multiple replaces, so replace in Java replaces all of them. Okay, there's also replace first, but that accepts not a character sequence, but rather a regular expression, and we're going to talk about that in the next lesson. Okay, so that's how you replaced all occurrences of a word inside a string. Now, how do you replace a single occurrence of a word in a string? Well, if you want to replace a single occurrence, what you do is you find the word, you get the substring starting from the start of the string until you reach the word, and then you get the substring after the word, and then you just join those two strings with another string which is the replacement. So instead of replacing, you just get the substring before the word, you get the substring after the word, and you join them with the replacement. That's it. Okay. So we implemented this text filter task, and from here on, we're going to be talking about efficiently building and modifying strings. Now, this replace function is efficient. However, appending strings one after the other, like I said in the beginning of the lesson, is not efficient. So we're going to be talking about how we can do that efficiently, and we're going to be talking about how we can use the StringBuilder class, what it is, why it's efficient, and so on. So what is the StringBuilder? The StringBuilder is similar to a list, actually, because notice this. A StringBuilder is just an array which contains characters, and these characters have a bit of an unused buffer at their end, usually. So a StringBuilder, this should look like what the list does. A list is just an array which actually has more elements than it needs so that it can efficiently add elements to its end. So a StringBuilder is the same thing, only for characters, and it's optimized to work for strings. So it has specific functionality which is string oriented. For example, it has a .append method which adds symbols to its end, adds strings, for example, or integers or something else to its end as sequences of symbols. So a StringBuilder is actually a special class which is a string which has more memory than it needs. And that more memory than it needs is used to add symbols into it. So since it has more additional memory, it doesn't really need to always, whenever you need to add symbols, it doesn't need to copy all of its items in a new place, which is bigger so it can accommodate all of the new symbols, because it already has some space in which it can put the new symbols. So that's what a StringBuilder is. A StringBuilder is created so you can modify strings. And let's actually see it before we see the slides. The StringBuilder is just, you can treat it almost as a string. So let's create a StringBuilder over here. Let's say this is a StringBuilder builder, which gets initialized by a new StringBuilder. Okay, so what can you do on the StringBuilder? Well, you can append symbols to it. So you can append, for example, hello. Then you can append a space. And then you can append the number 123. And then you can print this thing out on the console by saying builder.toString. That's how you convert it into a string representation. And if we start this code, we're going to see hello space 123 on the console. Okay, so that's what we got. Hello space 123 on the console. So unlike the string, however, this builder over here doesn't work as inefficiently when you're appending strings. So you could say, okay, well, why do I need this? Since I can simply say a string s, which is an empty string or a new string, or a string dot empty. Do we have that? No, we don't have that. Okay, so a new string or a empty string like so. And I can say s equals s plus hello, and then s equals s plus space, and s equals s plus 123, and that would yield the same result, right? So S will contain the same data that the string builder has. So if I print S on the console, that would give me the same result as printing builder.toString. Well, yes, but notice what's happening here. Every time you're adding something to this string S, you're actually creating a new string, and that new string gets assigned to this string. And in this step, again, you're creating a new string, and that gets assigned to this string. And here, you're creating a new string, and you're reassigning it back to this string. Whereas, notice what happens on the string builder. We simply call the append method on that string builder. That append method returns a string builder, true, but it also modifies this string builder. So it modifies itself. So the append method modifies the builder itself. It doesn't, unlike the concat method on string or the plus operator, it doesn't create a new object, it modifies the existing object. So it works with the same memory, it works with the same object. Now, occasionally, the append operation will generate new memory and copy values from the old memory into the new memory when the buffer runs out. But since it has a buffer, it usually can add items without having to reallocate its memory. So this means that this string builder is actually much more efficient than string concatenation, because it doesn't allocate a new object each time you allocate memory inside it. So this is one object, then a second object, then a third object, then a fourth object. Whereas this string builder over here will most likely use a single object and append inside it. It will allocate memory once, it will allocate more memory than this string, but since we know we're going to be adding multiple times inside it, that's why we're using the string builder, because this would be more efficient. Now, you don't really do this if you have 2 or 3 operations like so, but you do this if you have concatenation inside the loop. So if you're doing something n times, where n can be a large number, you're much better off using a string builder for concatenating your strings, and then you can simply say, for example, s equals builder.toString. So this allows you to build efficiently, for example, in a for loop, and then just assign back into a string so you can do any string operation you like. So that's what a string builder is. A string builder optimizes appending operations. So it's fast at appending items to itself, and then you can convert it back into a simple string, which doesn't have an additional buffer, and let's say print it on the console or save it into a variable and so on. Okay, so why do we need it? Again, because concatenating strings is a slow operation. Not that a single concatenation is slow, but multiple concatenations like this one is slow. Now notice this code, and it's going to show you how you can benchmark your code. We're printing a new date. What does new date do? Well, it creates a so-called date object, and that date object, when you haven't passed in any parameters to the constructor, initializes with the current time. So if you create a new date over here in your code, it calculates up. It gets printed up to seconds, but you can add some formatting strings which can tell it to print out to milliseconds, or you can just say dot get time, and that will print the current times milliseconds from the 1st of January 00 o'clock at on the year of 1970. So 1970, 1st of January 00. The number of milliseconds since then to now. Why is that specific date? Well, there are reasons, not going to cover them now, but you can Google that. So this is going to print you milliseconds, and then you can do the same thing over here after you've done some piece of code for which you want to know how fast it runs. So you do first printing of the time and the second printing of the time, and then you calculate the difference between these two. Or you can get the current time, save it into a variable, not print it, save it into a current variable, and then get the new time after you've completed this code. Then subtract the two variables, the first time and the second time, and you're going to get the number of milliseconds for which this thing ran. It's always a bit approximate. You can't measure it exactly precisely, but it's close enough. So when we ran this example some time ago, a lot of time ago, as you can notice, what we got was for this string concatenation of 1 million times adding the string A to a text, what we got was it's not more than a minute, but it's almost a minute. So almost a minute for 1 million operations. Why is this slow? Well, because each of these operations creates a new object. It doesn't work on the current text variable. It creates a new object, migrates all of the memory from the old object to the new object, meaning it copies all of the symbols inside this text to a new piece of memory, which has one element more. So if text was 5 characters, so let's say we have A like this, and we enter the loop, what happens is the new memory gets allocated with 6 elements, because here we're adding 1 element, and this A gets copied over here, this A gets copied over here, this A gets copied over here, this one gets copied over here, the last one gets copied at index, what's this index? It's index 4, right? Because there are 0, 1, 2, 3, 4 is the last index. So we get these copied into these indices, and then we get this variable which we're adding, and we append it to the end in the remaining symbols. Because we've allocated, in this case, 6 positions, and we set the new character A to the position at index 5, which is the 6th position. Okay, so this is when we have 5 elements, and when we have 6 elements, we need to copy 6 elements, right? Here we're copying 5 elements, then we need to copy 6 elements, then we need to copy 7 elements, then we need to copy 8 elements, 9 elements, 10, 11, 12, and so on, and those are a lot of operations. By the time we reach the length of 100, we've copied 5050 elements. You can calculate that, the sum of all numbers from 1 to 100. And from 1 to 1 million, well, it's a lot. It's 5 billion and 500, whatever. It's a lot. It's a very large number. So this doesn't really. It's not 5 billion. It's a lot more than 5 billion. Whatever. A lot of operations, because each time you're copying each of the items inside the text, each character inside the text, to a new piece of memory. So that's very slow. Whereas doing that with a string builder, it's the same code, those are the same operations, but you just do append. This does not create a new object. It occasionally does. It very rarely does. It creates a new string builder as often as a list creates a new array, right? Because the string builder actually works by using something equivalent to a list inside it. It has buffer space, and it appends inside that buffer space, and whenever that buffer space runs out, it allocates a new string builder, and it gives it even more buffer space. So the more often you increase the space requirements for a string builder, the more often it's going, the larger amount of buffer space it's going to be adding. So that reduces the amount of times it gets copied. Yes, it copies more elements, but it copies much less often, and that leads to very fast execution time, because it's just 1 million operations, and that's not a lot for a computer. Whereas here, as I said, it's a lot more than 1 million operations, because for the first operations it's 1 copy, for the second it's 2 copies, for the third it's 3 copies, and so on. Copying of 3 items inside a string, and then copying of 4 items inside the string where items are characters. And that becomes slower and slower and slower with the more iterations that this loop does. So doing it with a string builder yielded about a second of time. Pretty much a large improvement, right? So this is really significantly faster than using a simple string. So whenever you have a for loop like this one, and like the one we had somewhere in the beginning of the lesson, where we were talking about concatenating. So in this for loop, in this solution, this is slow. This is not a good idea. That's why I did it with a list of strings, an array of strings, which I joined. That's faster because we're not copying elements, right? We're just adding into an array, and we're doing the merge up, the string.join, only once. That's okay. But if you're doing it like this, each time you're adding a symbol, for example, you want to repeat the word 5 times, well, that would mean that the word has 5 symbols, right? Because that's how we implemented that. So we have A, B, C, D, E. That's 5 letters. So the first time you're adding it to itself, you're going over here and you're creating 10 elements. So it becomes A, B, C, D, E, copying these 5, and then adding the new A, B, C, D, E. And then this thing that has to be copied. So on the second iteration, we're doing A, B, C, D, E, A, B, C, D, E, 10 elements. We now copy 10 elements. And now we add the next one, for example, A, B, C, D, E again. And then on the next operation, we need to copy 15 elements. You get where this is going. So it becomes slower and slower on each copy. The solution I proposed was we just create these copies once. So we don't copy into the same object, we just copy into different objects. So we create A, B, C, D, E, then A, B, C, D, E, then A, B, C, D, E, then A, B, C, D, E, and then one more, right? 5 operations, A, B, C, D, E. So in total, I allocated 25 elements, whereas the first 3 iterations of this for loop over here would do 30 operations, right? 5 operations the first time, 10 the second time, and 15 the third time. That's just for the first 3 operations. It does more copies than I do, right? And then I join them. Of course, there are 25 more over here, but this grows as quickly as the other one. So the larger the word becomes, the slower this code gets and the faster my suggestion gets. But a string builder is even more efficient because it doesn't need to merge them up at the end. It just has them merged up while it gets constructed. And it's fast because it has a buffer in which it adds instead of creating a new object every time. Okay, so this string builder concatenation works pretty quickly. And you can test it at home. Of course, you're not going to get the exact same values, first off, because it's not 2018. You're not going to get the same result, but if you compare the execution of the string variant and the string builder variant, you're going to notice that the string variant is much slower than the string builder variant. And that's what we really care about in programming, which one of the two, which one is faster, because on my computer is going to be one length of time for string concatenation. On your computer is going to be a different length of time, but the ratio of the string builder time and the string time is going to be similar between my computer and yours. So as quicker it is for a string builder to operate on my computer than a string on my computer, the ratio is going to be similar for your computer too. And that's what we usually care about in programming when we're trying to optimize. We're trying to make code more efficient. We're trying to use methods which allow our code to work much faster than when using other methods. Okay, so that's how you use a string builder to construct strings. If you have a loop, you just append into the string builder, and then you say text.toString, and that gives you a normal string on which you can operate. Okay, so this is the append method. The append method can accept a string. It can also accept an integer, a double, and so on, and a lot of other variables. And it just simply appends to the end of the string builder. It's the equivalent of saying string s equals something, and then saying s plus equals, for example, hello. So this is the same as having a string builder on which you append hello. It's the same in result, but it's not the same in efficiency. So this one should typically be more efficient. And if you're doing it a lot of times, this is definitely more efficient. Okay, it also has a length, just like the string class, the string objects have a length, and it returns the same thing which a string would return. So if you have an empty string builder and append this string into it and then ask for the length you're going to get is the length of the string you just appended. If you append multiple strings, it's going to be the sum of all the strings you appended. You can also construct a string builder directly from a string. So if you have the string hello, instead of appending it as a single append operation, you can provide it over here as a parameter for the string builder, and you can initialize a string builder directly from some text. So you don't need to create a string builder and then append the text to it. You can directly initialize it with the text. You can also give it a hint about capacity. So if you don't have a text yet, but you kind of know how many elements there are going to be, you can add them over here. So if you know that there are going to be, let's say, at least 100 elements, well, you can tell the string builder to initialize with a buffer of 100. So it doesn't have to reallocate. It will still do it efficiently, but you're reducing the number of reallocations that are going to happen. Again, you do this if you have an idea of how much memory you're going to be needing approximately. You can do this, you can provide this capacity. And then again, it will still reallocate memory if it needs to, but you're reducing the number of times it would need to reallocate memory. Okay, so that's the length method, the append method, and there's a set length method which removes any characters, or it cuts off as many characters as you would like. So if you want to initialize with this string and then say set length of 5, it's going to cut out everything after the hello word. Okay, you can ask it for character at the same way as string. The same way you can ask a string for a character at a certain position, and in addition to that, since the string builder is not a string, it's not immutable like the string. For a string builder, you can say, again, you can say character at, which does the same thing as the string does, but you can also say set character at, which is the same as setting an index in a list. So you provide the index, for example, you say set index 3 to the letter A. So you provide an index and a letter for this set operation. So again, it's like in the list you can set elements, in the string builder you can also set elements, unlike the string where you can't set elements. Okay, so that's the character at, and there's also an insertion method which allows you to insert a string at a specific index. So this does the same thing that inserting in a list does. It places the item which you want at that index and moves everything to the right. So it shifts everything from that index to the right, as many positions as it needs to shift it, so it can accommodate this string. And it accommodates that string at that index. So that index becomes the index for this substring which you're adding. And if you say index of, that's going to return you this index. And all other symbols get moved to the right. Okay, so that's what the insert does. There's also index of, works the same way as it does for strings. Again, most of these operations are similar to the operations for a string. However, the modifying operations for a string builder actually modify the string builder instead of simply creating a new object. Whereas for strings, they create a new object. Okay, so the other thing you can do is the replace operation. Now, this one's different than for the string. For the string, you provide a string which needs to be replaced, and it gets replaced in all places. Here, you provide a start index and an end index, and that range of characters gets replaced with a string you provide. That's a common occurrence. For example, if you say, if you have a string builder with this string in it, and you replace symbols from 6 to 11 with George, it's going to replace Peter with George. So it's going to delete all these characters and then insert George at this position and move everything to the right. So it's basically a remove operation followed by an insert operation. Okay, and of course to string does the converting back into a string. So again, the methods are very similar to the ones you have for string, with the difference of that replace can't replace by a given string. And if you want to do a replace by a given string, how do you do it? Well, you start a search with an index of, you check whether, let's say you want to replace old string, so you have a parameter old string and you want to replace it with the new string. Well, one option would be to actually get the string, call the replace method, and then create a string builder with the result of the replace method, because that's what replace does on strings. And actually, that's a common way to do it, because if you want to do a string-specific operation which works on the entire string, that is optimized for the string. It's not appending to a string. It's just, for example, replace will find all occurrences, allocate enough memory for the replacement, and then copy all the items inside the replacement. That's one it's one operation for the entire string. So it's it will not do replace operations multiple times on the string. It will just do a single one for loop sweep of the entire string, and that will give you the that will do the replacement for you. In a string builder, you don't have a replace by a string, by an old string with a new string, exactly for that reason, because you don't need it. You can do it on a string and then create a string builder with that replaced string. That's the idea. But you can do replacing of ranges of symbols, which you can't do with a normal string. And that's why this replace operation is implemented here. Now, if you really want to do a replace operation on a string builder, which accepts a string parameter old string, what do? Well, you search for the index of old string, find that old string. So you find its index, you find its starting index. So this is its starting index, and you find its ending index, which is its starting index plus its length. So this is its starting index, and its ending index is start index plus old string. Let's move it to the next line, plus old string dot length, and that gives you the end index. So here we've just implemented replacing by a string by just finding the old string, so index of old string, and then that index plus the string's length, and you pass those into the replace method of a string builder, and you have that replacement. And if you want to replace all of the occurrences of that string, well, you just run a while loop while you can find that index, while you can find that old string, you do this operation which we just described. Okay, and again, the string converts that back into a string. But I wouldn't do replace operations on a string builder by an old string, replace operations of the type replace an old string with a new string, because I don't really need to do that, right? I have a string class which can do that, and I can convert, if I need to do it on a string builder, well, I convert the string builder into a string, then I do the replace, then I convert the string back into a string builder by saying new string builder and passing in the replaced string, and that's it. It's not super efficient doing it this way, but writing a for loop which replaces each iteration and each substring until there's no more occurrences isn't much faster either. There is a way to implement it quickly by running a for loop and copying symbols directly, but that's too much hassle for most of the tasks we're going to be solving now. So for average running time operations, when you're not really chasing super efficient code, it's okay enough for you to just copy back into a string, do the replace, and then copy back into the string builder and do whatever operations you need. Okay, so we covered this lecture. I showed you the string builder. Again, avoid any, if at some position you have a for loop which is appending to a string, replace that string with the string builder and use the append method of that string builder. Do not do for loops like this one over here. Do not do for loops like the one in this solution, because they are slow. If you use the same code but replace this with string builder, and it gets initialized with a new string builder, and this method becomes not plus equals, but it becomes rather dot append word, this becomes extremely faster, a lot faster than string concatenation. So anytime you have this type of string concatenation, just change it into a string builder appending, and then just have this result printed as dot to string. That converts it back into a normal string, which you can print on the console, save into a variable, and so on. That's probably the main takeaway from this lecture. Do not use strings for multiple concatenations. Use a string builder for that. Okay, so what else did we learn from this lecture? We learned that strings in Java are immutable, meaning that any operations like replace, substrings, and so on will just create a new string which contains the result. Otherwise, you cannot change characters of a string, you cannot split a string itself, you cannot change the content of a string, but you can create a new string which is the split string, or the string with something removed or something replaced, and so on. And it supports any type of of language which you can think of. So you can have pretty much all languages on the planet can be represented in Java strings. Now, we saw concat, which is the same thing as plus equals is, actually as plus is. So concat is the same thing as just saying one string plus another string. We saw index of, which gave us the index of a substring inside a string, and I showed you additionally how you can search from, not from the start of the string, but from a certain position in the string, and we also saw last index of. We saw contains, which is the equivalent of doing index of and checking whether that index of returns -1. We saw substring, which gave us a part of a string. We saw split, which gave us multiple strings split by some separator, and we saw replace, which replaced some string in a string with another string, and we saw that StringBuilder is the efficient way of appending to a string, of concatenating strings. So never concatenate strings in a loop multiple times onto the same variable. Instead, use a StringBuilder for that. Okay, so I hope this was useful for you. As always, if you have any questions, please ask them in all the channels we have provided you, and see you next time.
Did you like this lesson? Do you want more? Join the learners community at softuni.org. Subscribe to my YouTube channel to get more free video tutorials on coding and software development. Get free access to the practical exercises and the automated judge system for this coding lesson and many others. Get free help from mentors and meet other learners. Join now, it's free. softuni.org